Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. How are you? I hope all of you are in good condition. During this pandemic, you must stay healthy and stay safe. And the most important is don't forget to be happy. Okay guys, you already know about algebra when you were in junior high school, right? Surely, what you have in mind about algebra is the algebra is about numbers and letters. Well, on this opportunity, we will learn together about quadratic equation. This quadratic equation is still about algebraic shape, but this time we will learn quadratic equation not only about numbers and letters, but also with a geometric approach. Wow, how is that? Are you curious? Okay guys, you will study with me. I am Kurrotul Hasanah from the Mathematics Education Study Program at the State University of Surabaya. Just go ahead and let's go. Are you know guys? This picture is Muhammad bin Musa al-Khwarizmi. Al-Khwarizmi was an expert in mathematics, astronomy, astrology, and geography. He comes from Persia. He was born around 780 AD in Khwarizm, now Khiva, Uzbekistan, and died around 850 AD in Baghdad. And the works of Al-Khwarizmi are: first, he wrote about algebra, geometry, and astronomy. Second, he wrote a book entitled Hisab al-Jabar wal Muqabalah. In this book, Al-Khwarizmi developed ways of solving quadratic equation with geometric approach. The title first introduced the term algebra and contains ways of solving positive roots of polynomials up to degrees 2. This book is called The Foundation of Modern Algebra. Al-Khwarizmi developed how to solve a quadratic equation that we are now familiar with, complete perfect square. And third, he wrote a second book is entitled Algoritmi de Numero Indorum. This book about the Hindu-Arabic numeral system. This book is an introduction use of the zero number in the place value and algorithm term. Okay guys, we will study quadratic equation with the source from Al-Khwarizmi's book entitled Hisab al-Jabar wal Muqabalah. Actually, in his book, Al-Khwarizmi didn't use any symbols, so it is necessary to write it in the notation that is known today. In here, I try to repackage the quadratic equation problem in Al-Khwarizmi's book with a realistic mathematics education approach. Let's see together. To make a base for sticking campaign poster, a rectangular wooden plank is needed with a length of 10 meters is longer than its width, and an area of wooden plank is 39 square meters. Calculate the length and width of the wooden plank. Let's try to solve this problem with geometric approach by Al-Khwarizmi. Now, we try to illustrate the picture from the problem. We have a rectangular wooden plank. It has length and width. We also have information that a length of 10 meters is longer than its width. So, the length is x plus 10 meters. And a width is unknown. So, the width is x meters. We also have information that an area of a rectangular wooden plank is 39 square meters. So, we can write area of wooden plank is equal to 39 square meters. We know that area of a rectangle is length times width, and the area is equal to 39. So we can substitute x plus 10 as the length and x as the width, which is equal to 39. Based on distributive properties, we get x squared plus 10x is equal to 39. This form is known as a quadratic equation. So, how did Al-Khwarizmi solve the quadratic equation problem, which is x squared plus 10x is equal to 39? Al-Khwarizmi said in his book like this: a square and 10 roots are equal to 39 units. The question therefore in this type of equation is about as follows. What is the square which combined with 10 of its roots will give a sum total of 39? The manner of solving this type of equation is to take 1/2 of the roots just mentioned. Now, the roots in the problem before us are 10. Therefore, take 5, which multiplied by itself gives 25, an amount which you add to 39 giving 64. Having taken then the square root of this, which is 8, subtract from it half the roots, 5 leaving 3. The number 3 therefore represents one root of this square, which itself, of course, is 9. 9 therefore gives the square. To understand the meaning of Al-Khwarizmi's explanation, let's see how Al-Khwarizmi translates from algebraic shape to geometric shape. Earlier, we have x squared plus 10x is equal to 39. We can draw square with the length is 8 and the width is 8 plus a rectangle with the length is 10 and the width is 8, which is equal to 39. After that, we take 1/2 from the rectangle, so we get two rectangles with the length is 5 and the width is x. After that, we construct like this. So, we have a square and two rectangles, which is equal to 39. Before we have construction like this. Right? So, after that, we make a square again, like this, with the length is 5 and the width is 5. So, the area of white square is 25 square meters. It is equal to 64. We get 64 from 39 plus 25. From the last picture, we have a big square, which is consists of a purple square, two blue rectangles, and a white square. Right? So, we also know the area of a big square is equal to 64. And the formula for area of a square is side times side, which is equal to 64. After that, we substitute x plus 5 as side, so we get x plus 5 times x plus 5, which is equal to 64. The square root of x plus 5 times x plus 5 is x plus 5, and the square root of 64 is 8. So we get x plus 5 is equal to 8, and we obtain 8 is equal to 3, because 8 subtracted by 5 is 3. So, the length of the wooden plank is x plus 10 meters is equal to 3 plus 10 meters is equal to 13 meters, and the width of the wooden plank is x meter, which is equal to 3 meters. So guys, from all my explanation, we can conclude that first, the quadratic equation that we study today are the work of ancient mathematician, that is Al-Khwarizmi. Second, algebra in quadratic equation is not only about numbers and letters, but also more meaningful with their geometric representation. And third, we can use a geometric approach to solve other quadratic equations. It means that you can apply this approach for other quadratic equation problems. Now, It's time to you practice, guys. Actually, this problem is listed in Al-Khwarizmi's book. Let's see together. Please create model from the quadratic equation and finish with the Al-Khwarizmi's method. If someone say you divide 10 into two parts, multiply the one by itself, it will be equal to the other taken 81 times. Computation, you say 10 less thing multiplied by itself is 100 plus a square less 20 things, and this is equal to 81 things. Separate the 20 things from 100 and a square and add them to 81. It will then be 100 plus a square, which is equal to 101 roots. Half the roots, the moiety is 50 and a half. Multiply this by itself, it is 2550 and a quarter. Subtract from this 100, the remainder is 2450 and a quarter. Extract the root from this, it is 49 and a half. Subtract this from the moiety of the roots, which is 50 and a half. There remains one, and this is one of the two parts. And here is the algebraic shape of the problem. X is equal to thing or roots, so we can write 10 minus x square is equal to 81 x square minus 20x plus 100 is equal to 81x, and we get x square plus 100 is equal 101x. So please try by yourself, guys, and good luck. And it is all from me. Hopefully it is useful for all of you. I hope you learn from here that mathematics is interesting, and it is not only about numbers, but can also be represented in geometric shape. Okay guys, thank you for your attention, and last I say wassalamualaikum warahmatullahi wabarakatuh.